Hello everyone. My name is Abhishek, and in this video, I'm gonna show you my final year project. Before actually I start giving the demo, let me first quickly set up the process and set the project up. So, first, I'm trying to start the backend of this project. So, as you can see, the server has started running. So, yeah, this is the backend server that has been hosted. And now let me quickly set the front end up. So, I've used React to design the front end. So as you can see, the title of our project is Homomorphic Encryption Based Secure Video Content Analysis. So before I start giving the demo, let me explain the main objective of a project. So the main important object of a project is to compare two videos without actually decrypting them. So as you can see, these days cloud platforms have been widely used like almost everywhere uh, for every kind of sector like entertainment, medical, surveillance systems, etc. So cloud platforms have become a vital source for storing such kind of information. And information, I mean video information, which could contain a lot of sensitive information. Uh, Videos usually contain a lot of actions, moments, human existence, human moments. So there could be a lot of sensitive data and information. And apart from that, various entertainment platforms have their own content uh, that have proper authorization. Like uh, like if you take Netflix, they have videos and you have to access them using a proper subscription. Without that, you cannot access them. But there are cases where some people somehow access them and then provide it outside for free. So what we call that is piracy of content. So the main objective is in usually we store videos in cloud platforms in an encrypted format. So cloud platforms cannot decrypt those videos because that can violate the rule of security. So what we have brought up is we designed an idea and a system that will allow the cloud providers or any other person to compare two videos and tell them if they are same or not, like redundant or not, without actually decrypting them. So the main algorithm that we used here is homomorphic encryption. So homomorphic encryption is known for its amazing computational capabilities and the idea of storing information within the encryption itself. So various kinds of information can be encrypted within the encryption ciphertext itself. So that's the main objective. Apart from that, let me show you the architecture of our system first. So this is the proposed architecture. So initially from the client side, you will send an input video. So for that video, what we are trying to do is we will be sampling the frames. Like based on the length of the video, we will be extracting individual frames based on specific intervals. So at specific intervals, we will be extracting the frames. Then we are using a ResNet 18 convolutional neural network model. So this model is usually a classification model. So what we did is we removed the final classification layer and we used that previous layer which consists of embeddings. So we work on that embeddings, and after that for those embeddings we perform temporal aggregation. So after the temporal aggregation, we get a 512 dimensional fingerprint vector. So like we named it as fingerprint because that 512 dimensional vector consists of all the information like visual information or various kinds of information, color information, etc. of that particular video into a compact format. So that's the main idea of this fingerprint. So why we are using this fingerprint is because it is lightweight and it reduces computational costs. Because homomorphic encryption itself is a very expensive operation. So in order to reduce costs here, we are instead of applying encryption end to end for a particular video, we are using this fingerprinting concept. So after that, we also experimented on using quantum-based feature mapping. So it maps higher dimensional feature into a it maps lower dimensional fingerprint into a higher dimensional, which enhances the richness of the characteristics of the video. And that's how it works. This is the main architecture. Let me also show you the fingerprint extraction flow, how the fingerprints are extracted. So input video is taken and frames are sampled. So we may extract frames based on the length of the video. Then we use ResNet 18. So from that we get 512 dimensional vector for each and every individual frame. So for all those frames, we perform this temporal aggregation. So this is called mean pooling. So for that, after performing that, we get this final output, which is a 512 dimensional. So that is the main execution flow. So this is the main web page. So here you can upload a video. So let me choose a video first. So first let us try an original video. So this recording too is of my phone recording. Let me try this. So as you can see, it is taking some time because the video is a bit lengthy. So for now, if you look at the database is completely empty. So for the first time, this video has been ever recorded. So that's why the similarity score doesn't show up and the video is identified as unique and the confidence is medium, that is other stuff. But this video is unique. Like there's no copy of it. There's no modifications of it now whatsoever. Nothing else has been done on this video. Now, if I try to upload same video, but this time I did some modifications, like usually piracy content creators, what they do is they apply some kind of transformations to the video, right? Like applying the cropping, changing colors a bit, whatsoever, like they do, right? So this is recording to mod. So if I try to upload this video, let us see what would be the outcome. So as you can see, a duplicate video has been detected and the similarity score is also shown here. So all of this process happens without actually decrypting the video because we already, before uploading videos into cloud, we already we will be already applying homomorphic encryption. So because of homomorphic encryption, we can detect whether a video is copy or redundant without actually decrypting them. So it's a big advantage for cloud providers to provide security without actually decrypting. So this way, for various platforms like for like cloud providers, content creators, filmmakers, like any other kind of people, surveillance system managers, so they can analyze the content without decrypting them. So this is the project. So if you can go see the dashboard, it usually shows like a total number of videos. It's like a complete system. So, and there is quantum view. So as I already told you that quantum is also integrated. So it usually shows the difference, like both of them works hand in hand, but some as the number of videos in the database increases, the quantum inspired feature mapping will definitely help a lot because as the size of database gets increased, the knowledge base will be increased so that decisions can be made properly and more effectively. So that's about this encrypted decision analysis. So you can also check the performance characteristics here. So that's about it. That's about our final year project. Thank you.